Okay, guys, so now let's start up with segment routing. So, first of all, we need to have the clarity on this thing, guys, that what is segment routing? Where segment routing plays role? People will have so many misconceptions regarding the segment routing. I have seen people were saying that segment routing replaces MPLS and so many stories, but that's not true. Segment routing is one of the MPLS control plane protocol. Okay, so MPLS is a data plane. As I mentioned in our first session, MPLS is a data plane, and we need to have the control plane for that. Each and every data plane protocol needs to have the control plane for that. So MPLS is data plane. Then below that you need a control plane. Now for setting up control plane, what protocol we can use? So for setting up control plane, we have option to use the LDP, we have option to use the RSVP. That was earlier. That was the only two options earlier. Now we have the third option to set up the control plane, which is segment routing. Segment routing in one of the control plane protocol for MPLS, which can replace LDP and RSVP. Okay, so like the way LDP do labeling, same way segment routing will do labeling. The way RSVP will do traffic engineering, same way segment routing can do the traffic engineering. So this segment routing, I can say, is a mixture of LDP and RSVP characteristics, and it can replace both of them. So I have a LDP network, I can replace with the segment routing. Now, the first thing, when I say replace, the first thing which comes in your mind is we are talking about service provider network. We are talking about telecom network, where if we need to make a single change, it will take a long time. Why? Because the network is so much complicated. The network is so much messy. We won't allow to have the maintenance window downtime in that network. So you are saying changing control plane. That means to say putting entire network down. Actually, not. When Cisco has designed the segment routing, they keep this thing in the mind that when we say the migration of control plane, it is not something that you can do over one night. Okay, there are maybe millions of boxes you have where you need to replace this. You cannot do overnight, and you cannot keep half of the network like that way, half of the network like previous. You cannot keep like that way also. So Cisco will have this thing in their mind while designing the segment routing. So they are saying that you enable segment routing, it won't affect anything. When you enable the segment routing, it won't affect anything. It is just going to be it's just going to be executed on your router. That's all. The labels will come in place when you change your preference from LDP to segment routing. Okay, so these are the migration scenarios which I will highlight later on, but right now today's session is more on the introduction part, the introduction of the segment routing. So the first thing which come in your mind right now, it's all okay, it can replace LDP, RSVP, but the thing is, why we need this, why we replace LDP and RSVP? We are good with LDP and RSVP. What is the requirement to getting it replaced? So requirement comes from nowadays very famous word, software defined. So we have, so firstly it was software defined network, which was a basically something at very high level. People were not have much clarity on that what exactly it is. So then slowly Cisco was coming up with the different kind of solution which are software defined, like software defined WAN, which is one of the solutions, software defined LAN, which is also known as software defined access. Okay, then similarly we have software defined service provider network also. How we can leverage the SDN stuff over our telecom network, how we can leverage automation in the telecom network, how we can leverage the intelligence of software defined network in the telecom network. So for that, we need to get into the telecom network. First of all, understand the network and map the network with application requirement. so that when application come in, it can understand how your network behaves, how your network process the packet, what is the forwarding mechanism, and based on that it will forward the packets. So segment routing, again also known as source routing. So before we proceed to understand any kind of solution, what I believe is we need to know the problems first. Then only we can proceed with the solution. So let's talk about the problem first of all. What was the problem we were facing with traditional LDP and RSP? Why we need to jump into that segment routing? So let me just make some drawing. I'm not good in the drawing, so just try to understand. This is my data center. Okay. Then here I have my SP core network, which is fully matched. And here is your end user. Okay. So this is X company whose end user is sitting here. So this end user is supposed to access some XYZ application which are hosted in this data center. The application is hosted in this data center. Today, for some testing purpose or some project purpose, what the company has done. First of all, we need to understand what is actually matters to the end user. What is the actually matters to the customer? Does it really matters to them what type of network we are using? Does it really matters to them what type of technology, what type of forwarding mechanism, which all protocols we are using? No, customer has nothing to do with that. Customer will have only one concern: application access. So the first thing which we need is to understand customer pain. Customer pain is application access. We need to provide them a smooth application access. Customer happy, then business happy. So now what customer is doing, just try to understand that. Change its color. So customer is hosting one application in his data center, which is a voice and video application like Cisco WebEx or Jabber or something like that. It's basically hosting one voice and video application in its data center for a project basis. And this data center is connected to this SP core, and SP core connects to the end user, same SP core. Now customer is telling to SP core, that service provider, that hey, I have an application which is voice and video. So what is the requirement of voice and video application? What is the requirement of this application from network? The requirement is low latency. The requirement of this particular voice and video application is low latency, doesn't require much bandwidth. It require a path with the low latency. Now customer will say to the service provider, hey, I need a path with a low latency. Why? Because my application is a voice and video. So service provider core will have a path here which is low latency. So he need to coordinate with to the network engineer of SP core. SP core network engineer need to analyze entire network, get one path with the low latency. Now he created a end-to-end tunnel, which is traffic engineering tunnel. So we know that it's a per hop basis tunnel. So we are creating end-to-end tunnel for this voice and video traffic, which is hosted here. So the traffic comes in into the service provider core and then sits into these tunnel using whatever traffic engineering mechanism, and I will give and deliver. That's okay. So how much task I have to do as a from a service provider perspective? I analyze my entire network, somehow find out a path with a low latency, create a tunnel end to end, maybe in the thousands of hops. Okay, and then I provided this to the network. After 1 week, service provider, the end customer decided not to use this application. Why? Because it was just a testing purpose, it was just a project purpose. Now another application, FTP based application, file download. It's a file download server. What this needs, what a file transfer application needs from network, the file transfer needs higher bandwidth. So this particular application's requirement is higher bandwidth. Again, customer tells service provider, hey, my that application is gone now. My another application is a file download, file transfer application, which requires higher bandwidth. Give me a path with higher bandwidth. Okay. Again, need to analyze the SP core. Created another number of tunnels for reserving the path with higher bandwidth. Okay, so now traffic comes in of this application, needs to routed into the tunnel and going all the way till to the end customer. What about these tunnels? If you guys have ever experience with the telecom network, if you see, if you see the network, you will have number of tunnels configured. Okay, you have number of tunnels configured, and those tunnels, you don't know why they are there, you don't know why they are configured, which application is transmitted through those tunnel, you don't have any idea. And on top of it, you don't have courage to touch that tunnel, because when you don't know what traffic is sending through those tunnel, how can you touch that? So there are thousands of tunnel configured on the router unnecessarily, which are not carrying any kind of data, but you cannot touch it. Don't know which application, which customer, maybe not right now, tomorrow someone starts sending traffic to this tunnel. I don't know. I cannot touch it. And customer will always have those dynamic changes based on the application, because nowadays applications are very dynamic. They change their behaviors on the fly. So we need to understand, our network need to understand the application pattern. Okay, that is one thing where I have that unnecessary configuration in my network which I cannot override. Now second thing, how can I recognize the application? Okay, how can I recognize the application? He is saying voice and video. Tomorrow he is saying FTP. This application, FTP application, is having IP subnet of 10.1 today, for an example. Tomorrow, due to some acquisition, migration, whatever reason, IP got changed, become 10.2. What? Now what? Now what is happened with service provider code? Can he recognize my application still? Can I use still same configure tunnel? No, cannot. Because my only visibility in the network is IP, or max you can take port number. So either IP or port number, that is the maximum thing which I can get out of from the application. I don't have anything else. I don't have anything other than that, any visibility. So due to the lack of visibility, I cannot create change path dynamically. I always dependent on the IPs. IP change, again configure those tunnels, because that is the only source of recognition I have for the application. So these are the different use cases. They are different kind of problems which service provider were facing since long. LDP, RSVP, traffic engineering, everything is there, but still they are facing these problems. So they need to work out on a particular solution. So they came up with the solution called, so this is clear, I guess. Okay. So let me erase this up. So they came up with the solution called AER, application engineered routing, in this service provider. Application engineered routing is the solution which will do the engineering into the network based on the application needs, not as per what we configure. No, let application derive the path into the network. That is your AER. So what you need for AER? What are the components you need for AER? First thing, application. Whatever application you are using, you can use all of them. Second, your software defined controller. You need a software defined controller. Third, a segment routing enabled network. And the best part is, no new hardware needs to be announced to enable segment routing. It's just a software upgrade. From 6.0 onwards, segment routing is enabled. So you can utilize segment routing on any hardware which supports from 6.0 onwards iOS XR. It is supported on iOS XE and iOS XR. No specific hardware requirement. Okay. So these are the components of AER, application engineered routing. This is the solution. See, I haven't touched the segment routing yet. Keep this thing in mind. I'm just focusing on the solution, how we can resolve those problems. So now let's get back to our problems and see how this thing can resolve that. So let me just draw up little quick same scenario. Go back to the previous slide. So my scenario was data center, SP core, and the end user. So DC is connected with SP core. SP core connects the data center to the end user. Now we have a new component here which sits somewhere here. I'm not going into integrity of everything, guys. I will explain technicality of all this later, but first of all, we need to understand the solution. We need to know why segment routing. What is the role of segment routing? Then only we will get into the segment routing and see the technicalities of that. So this is the new component which we have. Sorry. This is the new component which we have, which is your controller, which is a SDN controller. Okay, or it doesn't need to be a very full orchestrator controller. It can be iOS XR also, which is a PCE or XTC controller. Okay, we can use that also. Now this controller will have so if you want the application integration, it has to be a SDN controller. So this is my application which will get integrated to the controller using some kind of API which is supported, and this controller will have visibility into SP core network as well using a protocol called BGP LS. This is the protocol name called BGP LS, BGP link state. This is the protocol which is used to share the network, the service provider core network information to the controller. Now, what happen is, let's talk about our previous scenario. The customer is hosting one voice and video application into the data center. So this is your voice and video application into the data center. Now this application needs to have a low latency path. Okay. So earlier what I was doing entire stuffs here, configuration, analyzing of the network. I don't need to do anything now. So this should be SR enabled. That I need to make sure that this network is SR enabled. End to end is your SR. This is something which I need to make sure. Then what happen is, as it share all the information to the controller, again as I mentioned, I will get into the technicality of the information, what kind of information is shared, how we can fetch the information, all these things later on. But right now you keep this thing in mind that my entire network information is shared with the controller, and controller will have that much of intelligence that based on the application he can find out the best path. So how will he get the information from the application? Because the application is already integrated with the SDN controller. SDN controller which will fetch the needs of that application. This application need what? It's a low latency, it's a higher bandwidth, or it's some other type of constraints which this particular application required. So right now our constraint is low latency. So my application required a low latency path. So he will feed that information into the controller. Controller is already having the visibility into entire network. So let's say this is the path, which is a low latency path. Okay. So as it is enabled SR will unique allocate a unique ID that is called segment ID. Okay, to each and every node. It is individual to node, not prefix, no path, individual to node. So it will allocate a unique SID. So I'm just taking an example, like A is the SID of this router, B is this router SID, C is this router SID, and D is this router SID. So A, B, C, D are the SIDs of the routers. Okay. Now, as we are sharing information with the controller, we will share this ABCD information also, this SID information also with the controller. Now controller will have that intelligence, will have that capability that he can find out the path with the low latency or some other constraint in my network, and he will get those SIDs. He will fetch those SIDs and he will create a list of SID. Okay, you want a low latency path. Low latency path is A, B, C, D. So he will create a stack. He will create a stack, or also known as SID list, segment ID list. Okay, so also known as SID list. So he will put, first of all, go to A, then go to B, then go to C, and then go to D. So these are the list of SIDs, okay, which he get from the network based on the application need. Now he will give this SID list to the application itself. Guys, put focus. I'm not configuring anything on the router. I'm not saying anything to the router. Routers are just SR enabled. They have SID. I get that SID. Create a SID list and let the application know. I will say that, hey, you will have, when you send the packet, you put this stack into your packet. So this is your actual packet which application is hosted. This is your actual packet. And then below the packet you will get that seed list. So A, B, C, and D. So you will get your stack of seeds inserted into your packet itself. No configuration on the router. Your packet knows itself where I want to go. Earlier, what happened? You were doing destination based routing. When packet arrives, it will look into the destination IP field. Based on that, it will allocate label and then packet will get forwarded. Now, situation is different. It's not destination based routing. It is source based routing. Source already know where I want to go. I'm not asking to the router. So what I'm doing, I'm reducing the my process on the router. I'm reducing the job role of my router. I'm not saying router to decide where to go. Packet is already decided where to go. You just tell him that okay, this is there. So now what happen is when packet arrives onto the router, no need. Router doesn't need to decide. He's saying, hey, I want to go A. Router will say, I am A. Okay, that's good. Let's pop the A. Now next is I want to go B. Router will say, okay, you want to go B. This is B. Based on its IGP information, he will tell where is B. Okay, let me go to B. Router is not saying which path you take, which tunnel you take. You need to go into this tunnel. Nothing. He is asking, packet is asking, I want to go there. Router is not telling where to go. That's the main part here. So when it go to B, he will see, hey, I have reached B. Let's pop the B. And now I want to go to C. B will tell, okay, C is here because they have end-to-end reachability. They have IGP. So C will get to know that, okay, this is the C. So let's pop the C now and let's go to D. So C will tell, okay, there is the D. Now pop the D. I'm at the end host. Now let's deliver the packet to the end user. So isn't it easy now? Isn't it simpler now to understand? I'm not doing anything. It is something whose controller is deciding, segment routing is deriving. I'm just sitting and monitoring. That's all. I don't bother now how many applications this particular end user is doing. Only one time integration with the controller. That is also we have the automation tool which can auto discover the application into your data center, which we even don't need to integrate. It will get integrated automatically. What I am doing, I'm doing nothing. My application get integrated, controller will decide the path, get the information and feed it into the packet itself at the server, at the application, and then just forward the packet. So my forwarding mechanism, my path deciding mechanism is quite easy. Now the question is where SR role plays, where segment routing plays role here. Segment routing will allocate those SID values and those SID value will be shared to controller, and controller will use those SID values to select the path, because otherwise controller will not have any kind of information on the network which he can utilize and feed into the packet. See, the only information which controller can utilize and packet can accept is those SID values. I cannot get those SID values using my LDP and RSVP. They will do traditional labeling, which is per prefix based. But now I need per node based SID value, which can be utilized by the controller and can be feeded into the packet so that I can achieve the source routing. So I guess so far I am making sense. This is about the introduction to the segment routing. This is about all the wrong misconceptions of the segment routing. Okay, so I'm not getting much into the technicality because I guess we should have, I need to have some hands-on on it. So now I will resume in the next session, the segment routing stuff. Now let's time for the Q&A. Let's talk about the Q&A and let me know how's the session. Did you like that? See, Swaplin, LDP is doing label swapping based on the prefix. Each and every prefix will have one LDP, one label assigned to the LDP. Here, I have nothing to do with the prefix. I don't care about prefix. These are the unique values which are assigned to the nodes, which are assigned to the hosts, the routers, and based on those values the controller we're utilizing. Where in LDP we don't have anything which is assigned to the particular node, it's all based on prefixes. I don't care about prefix because I'm telling to application don't know anything about my service provider prefix. Am I right? That's LDP will assign whatever routing information you have in your routing table. It will assign label on each and everything. But here, nothing related to the routing, nothing relating to the prefix. I'm telling you need to go this node. How you reach to that node is based on routing. How you can reach that particular node is based on the routing. So I'm getting the information of specific nodes, and I'm utilizing those information by the controller and feeding it into the packet. So Umesh, SID values are itself is a MPLS label now in case of segment routing. In case of segment routing, there are no MPLS labels separately. Your SID values are using as a MPLS label. So when we have end-to-end SR enabled, your SID value will be used for forwarding the packets as traditionally done by the LDP label. So SID values itself is a MPLS label. It's not independent from it. Got it? So how source is getting the SID stack is source will fetch. So basically source is your application. Application is integrated with the controller. Controller will have list of SIDs. So when application tell I need a path with the low latency, controller will examine the network information which is get into from the service provider core network and finalize a path with the low latency. So then based on that particular path, what all nodes are coming in that path? So he will get A, B, C, D, which are your SID values. So he get that SID value, create a SID list, and send that SID list to the packet, to the particular application. So that source is getting the list of SIDs through the controller, who will create the SID list and send to the application, and then application, the source itself, will drive the packet all the way till end. Yes, Swaplin, SDN controller can have all the information regarding bandwidth, latency, link utilization, but it totally depends which type of controller you are using. So SDN controller is a very generic term. It can be a very it basically completely depends on what all type of features does it supports, what all type of information it can gather, and only that information it will gather. So if you want to utilize full flash, you need to have a controller who can support all this. So SDN controller is quite generic term. We need to be specific that which type of SDN controller. They are vendor based, they have different kind of solutions. So this particular solution is not specific to one vendor, that controller has to be a Cisco controller or something. It can be any open orchestration controller who can understand segment routing and who can get integrated with your application. That's all. So no vendor specific things and all. Yep. And one more thing I would like to add here is it doesn't need to be a full flash SDN controller, as I mentioned. It can be a just a path computation controller. Like Cisco is having PCE, XTC, it can be those also. But the only thing which you cannot get there is application integration. But the path can still be decided. SID list can be created based and can be feeded into the packet. The only thing is that you cannot integrate it with the application, so it cannot understand the application. So if you want that application drive the network, you need to have the controller who can get integrated. RSVP is just based on the again prefix destination IP, nothing to do with the application, nothing to do with the controller. You can do the central controller stuff there, but again, end-to-end tunnel, per hop tunnel, traffic engineering configuration, lack of visibility on the application side. It's all same old issues which I was explained earlier. Based on prefixes, not based on the nodes. And there is no control than how earlier voice and video. So again the same old story, you need to reserve the path, you create your traffic engineering tunnel, push the traffic of the application into the tunnel, and the how you will recognize the application is just based on the IP information. Just recognize the application, just stitched it to the steer the traffic into the tunnel, and it will get tomorrow IP changed, new tunnel configuration, application is no more there, tunnel configuration is there. So much human work is there. Now things are getting automated. Why service provider want to get automated? And there are many service providers in the world who are using segment routing right now with the full flash SDN controller, and they are utilizing this feature. Yes, segment routing doesn't require LDP or RSVP. It have features of both of them, which makes the troubleshooting quite easier. Okay, as because there is no signaling. This thing I didn't add because it's a part of some when I get into the technicality of the segment routing. But segment routing doesn't require any kind of signaling. Where LDP requires separate signaling, RSVP require dedicated signaling. The SR will use the existing IGP signaling. Segment routing is purely based on your IGP signaling, no dedicated signaling for it, so which make it lighter and easier to troubleshoot. It's like you are troubleshooting your IGP. That's all. Okay, so am I making sense? Any other question, guys? Okay. So I'm just closing that Q&A now. See you the next week, next session. We'll get more into the technicality of the segment routing. Guys, don't miss the next session. We are going to do good lot of stuff with the segment routing. Okay, guys, see you next week. Have a nice week ahead. Bye.